Wormholes are fascinating theoretical concepts in physics that have captured the popular imagination and have become recurring elements in science fiction, being used to travel throughout the universe. But do wormholes exist? And if they exist, how do they work? A wormhole is a theoretical concept in physics, like tunnels or shortcuts in space-time. Imagine that space-time is a smooth, flat sheet. A wormhole would be like a hole in that sheet that could connect two very distant places by curving the sheet. Instead of traveling long distances to get from one place to another, a wormhole could allow you to instantly get from one end to the other. It's as if we found a secret path that allows us to jump from one place to another without going through all the spaces in between. However, it's important to know that wormholes are theoretical concepts and the existence has not yet been proven. The idea of these fascinating objects is based on Einstein's theory of relativity and on the mathematical equations that describe the curvature of space-time. Scientific theories and equations. One of the equations that relate the geometry of space-time to the distribution of mass and energy in the universe is Einstein's field equation. Fully explaining the equations of general relativity would require a deeper level of mathematical and physical knowledge. However, in simple words, the theory of general relativity describes how mass and energy bend space-time around them. Imagine you have a heavy ball on a stretched sheet. The ball will cause the sheet to sag, creating a kind of well in space-time. The well is usually represented as a subsidence in the savanna. However, remember that this is only an inaccurate representation, since space is not two-dimensional but three-dimensional. So, subsidence caused by mass and energy occurs in all directions. That is, mass and energy are the main actors in the universe, and space-time is the stage on which these two actors move. But the stage is not rigid and static, but changes as mass and energy change. A wormhole is not mass or energy, but would result from the interaction of a large amount of energy that breaks the fabric of space-time. Wormholes have no mass, since they're cracks in space-time with a large amount of energy stored inside. The idea is based on the fact that a huge concentration of mass or energy would bend space-time enough to break it and make it connect with another point in the distant universe. This idea is known as the Einstein-Rosen bridge theory. The Einstein-Rosen bridge, or wormhole bridge, is a theoretical proposal developed by Albert Einstein and Nathan Rosen in 1935 as a mathematical solution within the theory of general relativity. This theory suggests that wormholes could be hypothetical connections in space-time that would act as shortcuts between two regions or even universes. According to the Einstein-Rosen bridge theory, a wormhole would be a tube that joins two distant points in space-time. This connection is formed through an extreme curvature of space-time, where one mouth of the wormhole is in one region and the other is in another region. The wormhole would act as a bridge or passage between these points, allowing transit from one mouth to another. This idea arose from the concept of black holes, which are so massive that their gravity doesn't allow anything, not even light, to escape from them. The mass of black holes is so large and dense that it could tear the fabric of space-time. In this way, black holes would be the entrance mouth of the wormholes, and the exit would be a white hole in another part of the universe or even in another universe. Both white holes and wormholes are theoretical concepts, but black holes exist and have been directly observed with telescopes. If you would like us to make a video where we talk about the black holes in more detail, let us know with your valuable comment. Now that we understand how wormholes work, the question is, how many types of wormholes are there, or rather, could there be, according to science? Intra-universe wormholes. These could connect two different points in the universe without altering time. A wormhole should be able to connect distant locations in the universe by space-time folding, allowing travel between them in less time than it would take to travel through space in a spaceship. Inner universe wormholes. These could connect one universe with a different one, also known as Schwarzschild wormholes. This allows us to speculate about whether such wormholes could be used to travel from one parallel universe to another, and reinforces the idea that a multiverse could exist, where our universe would be just one more universe among the infinite universes. Time wormholes. These would have an entrance and an exit at the same point in the universe, but at different times, so that you could travel to the future and back to the present through the same wormhole, like a time machine. However, according to the modern laws of physics, you can only travel to the future without a return ticket to the past. Thus, you could enter a wormhole today, exit 100 years in the future, and no longer be able to return to the present. Could we create or find a wormhole? As mentioned earlier, wormholes remain theoretical objects that have not been observed, but could we ever detect one? Many scientists say probably not, since wormhole stabilization requires an exotic form of negative energy. Negative energy is a hypothetical form of energy with a negative pressure necessary to counteract the force of gravity that would otherwise collapse the wormhole. For you to understand it better, gravity, as we know, tends to have a force towards the interior of objects. That is, if there's an object with mass, gravity bends space-time towards its center, causing other objects to be attracted to this. Negative energy would cause the opposite effect, a repulsion effect, in which gravity, instead of bending space-time towards the center of objects, would curve it outward, causing objects around it to be repelled instead of being brought. This energy would be the only way to prevent gravity from collapsing wormholes and keeping them open so we can transit through them. However, negative energy has yet to be observed experimentally, and its nature is still under investigation. It's also unknown where we might find a wormhole or how to create one. In addition, if we do find them, manipulating and controlling a wormhole would also pose difficulties, as they could be unstable and susceptible to external disturbances, making their practical use as shortcuts in space-time difficult. At present, there are various projects and investigations that are trying to reveal all the mysteries of wormholes. Some of them are the Large Hadron Collider, LHC. The LHC, located at CERN, is a particle accelerator that's allowed scientists to explore the behavior of subatomic particles and allows us to observe how mass behaves at the subatomic level. Many scientists believe that rifts in the subatomic world could sporadically spawn wormholes, but this is still an unproven hypothesis. Space telescopes and astronomical observatories. Scientists use space telescopes and observatories to study massive cosmic objects, such as black holes and distant galaxies. These observations are critical to gaining more information about space-time's nature and the universe's regions where wormholes might exist. Theoretical investigations and computer simulations. Many scientists engage in theoretical investigations and computer simulations to better understand the properties of wormholes and how they might form and sustain themselves. These simulations help explore different scenarios and conditions under which wormholes could be stable and usable as shortcuts in space-time. Wormholes are fascinating concepts that have captured our imagination for decades, yet their existence and practical use remain a mystery. As we explore the far reaches of the universe, we continue to search for answers to questions that challenge us and fill us with wonder. The possibility of wormholes invites us to dream of shortcuts in space-time, instant travel across vast distances, and perhaps even the possibility of time travel. Although we have yet to find definitive evidence for wormholes, your study takes us on an exciting journey of scientific discovery. It invites us to question the limits of our knowledge. These mysteries of the universe remind us that there is much more to discover and understand. Ultimately, regardless of whether or not wormholes turn out to be a tangible reality, the journey of exploration and the desire to understand our world drive us forward as a species. Let us keep the flame of research and the passion for knowledge alive, as these impulses allow us to pursue and perhaps one day discover the answers to the deepest mysteries of the cosmos. Do you think we'll be able to discover or create a wormhole someday? Let us know your opinion with your valuable comment.